Here is question number 21, everyone. A particle execute SHM has potential energy U naught sine square omega t. The maximum kinetic energy and total energy respectively are. We know very well that potential energy given by half m omega square y square and its maximum value U max can be written half m omega square a square. Similarly, the maximum value of kinetic energy can be written the same half m omega square a square, where omega is angular frequency, a is amplitude, and the total energy is always constant, that is half m omega square a square. So U max equals Ke max equals total energy. Now looking at the equation, U equals U naught sine square omega t. So the maximum value of potential energy is what? U naught. So here U max equals U naught will be equal to Ke max, and that will be equal to total energy. So we can say that both are U naught and U naught. Therefore option number 3 absolutely correct. Now move on to the next, that is question number 22. So here is question number 22, everyone. When an oscillator completes 50 oscillations, its amplitude reduced to half of its initial value A naught. The amplitude of oscillation when it completes 150 oscillations will be what? Now here the amplitude is continuously decreasing, so this is the case for damped oscillation. Amplitude decreasing, therefore damped oscillation. And we know very well that the amplitude of damped oscillation at any instant of time is given that A naught e to the power minus bt upon twice of m, where t is time and rest of the things, that is b upon 2m, constant. Now the time intervals are given. Suppose time period is capital T, so first time t1, that will be what? 50 capital T, 50 oscillation, and second time t2, that is what? 150 oscillation, so 150 capital T. Let us putting the values of time in the expression, we will get, if t is 50 oscillation, then amplitude is half, so A naught by 2 equals A naught e to the power minus 50 capital T B divided by 2m. Equation number 1, or let us simplify a little bit, e to the power minus 50 TB upon 2m equals 1 by 2. Let us write it, equation number 1. Now putting the value of time t2 as 150 capital T, we get the new amplitude A as A naught e to the power minus b 150 capital T divided by 2m. This can be further written as A naught e to the power minus b 50 t upon 2m whole cube. That will be automatically 150. Now this particular thing, 50 bt upon 2m, we already have written 1 by 2. So therefore A equals A naught 1 by 2 cube, and A will be given as A naught upon 8. Therefore option number 3 absolutely correct, will go with third option, A naught upon 8. Now move on to the next, that is 23 number. So here is question number 23, everyone. The equation of traveling wave is given by y equals a sine 2 pi alpha t minus beta x. The ratio of maximum particle speed to wave speed will be what? Where alpha beta are constant. Now we know the equation of plane progressive wave, which is given as y equals a sine omega t minus kx, where the wave is propagating toward positive x direction. Comparing it, we will get given wave is a sine 2 pi alpha t minus 2 pi beta t. So from here omega is 2 pi alpha and k is 2 pi beta. Now let us come to the question. Ratio of maximum particle speed. Maximum particle speed given by a omega and wave speed given by omega upon k. Taking the ratio, we will get Vp upon Vw, that is a omega upon k, that is omega omega cancel out, k into a. Therefore k, that is 2 pi beta and amplitude is capital A. So therefore the ratio is 2 pi beta into A, Vp upon V omega. So therefore we can say that option number 1 is absolutely correct. Now move on to the next, that is 24 number. Now this is question number 24 everyone. A car traveling with speed v by 50 toward a hill, where v is the speed of sound in air, sounds a horn of frequency 196 Hz. The number of beats heard per second by the driver when reflected sound reaches the driver is. Now the beat frequency is asked. We know that beat frequency here will be f dash minus of f, where f is actual frequency and f dash is observed reflected frequency of the sound. Now the frequency of sound observed by observer will be given as f dash, that is f1 v plus vo upon v minus vs, where v is the speed of sound, vo speed of observer, vs speed of source, as both are moving. So that's why we have used this formula. Now vo here given v by 50, vs will also be v by 50. The car is moving with v by 50 speed and observer will also be move with the same speed, that of car. Now putting the values, we get f dash equals f times v plus v by 50 upon v minus v by 50, that is f times 51 by 49. Now student, the beat frequency therefore will be f dash minus of f, which can be written f dash, that is 51 by 49 f minus f, that is 2 by 49 into f. Putting the value of actual frequency f, we will get the beat frequency as 2 by 49 into 196, and after solving we will get the value as 8. So the beat frequency will be 8, or you can say that the number of beats heard by the driver will be what? 8. So we will go with option number 1, which is absolutely correct. Now move on to the next, that is 25 number. So here is question number 25 everyone. An electric dipole of dipole moment P equals 6 into 10 to the power minus 4 coulomb meter is placed in a uniform external field of intensity 2 into 10 to the power 5 Newton per coulomb. Given in the figure, the angle between net field and external field at point A will be what? Now how many fields are existing at A? First of all, find out. External field E, external, already there, and electric field due to dipole. A is equatorial position for the dipole, so electric field will be what? Opposite to the direction of dipole at equatorial position. So that's why E due to dipole, or you can write E equatorial, will be this. So two fields are existing perpendicular to each other So the net field will be what? Resultant of them. So this is the net field E, and we have to find the angle this net field making with external field, that is theta. This theta we have to find out. So first of all, let us find E equatorial, given as short dipole. So that's why Kp by r cube, simply K already know, 9 into 10 to the power 9, dipole moment 6 into 10 to the power minus 4, divided by separation cube 3 cube, that is 27. And after solving, we get E equatorial as 2 into 10 to the power 5 Newton per coulomb, and E external given 2 into 10 to the power 5 Newton per coulomb. Now tan theta can be written as this upon this, that is perpendicular upon base, or you can write E equatorial upon E external. Since both are same, so that's why you will get 1 here. So tan theta is 1, therefore theta is 45 degree. So we can say that option number 1 is absolutely correct. We can go with option number 1. Now move on to the next, that is 26 number.